Hello friends, welcome back to my YouTube channel. So this is the second part of the lecture series for the nomenclature of different organic compounds. So in this part we will discuss about how to do the nomenclature of different types of cycloalkane compounds. Okay, so let's begin the lecture. So there are certain rules that you have to follow while you are doing the nomenclature of different types of cycloalkane compounds. So here I am going through some of the rules. So the first rule says that it is for very simple type of cycloalkanes, that is cycloalkane that do not have any substituents. So in that case you have to count what is the total number of carbon atom that this cycloalkane consists. Okay, so you can see that this is one example. If you count that there are total 1, 2, 3, three number of carbon atom are there in this cycloalkane. So in that case, you have to do the nomenclature in a way. At first, you have to add the word cyclo. Okay, so this word cyclo will emphasize that it is a cyclic or cycloalkane. Okay, after adding this cyclo, you have to simply give the normal nomenclature, that is for 3 carbon compound you have to put propane. Okay, so cyclopropane. If there are total 4 number of carbon atoms, then you will write cyclobutane. Similarly, if there are total 5 number of carbon atoms, then you will simply write cyclopentane, and as it is like this. Okay, so this is an example of very simple type of cycloalkane compound that do not possess any substituents. Now what happened if the cycloalkane compound possesses any substituents? So here is an example. You can see that this is a 6-membered ring and it possesses one substituent. So you can quickly identify that this substituent is nothing but isopropyl. Okay, so these types of nomenclature I have discussed in my first part of this lecture series. So if you do not go through that, please go through that first part of that nomenclature series, then come back to this part. Okay, so you can see that you can quickly identify that this is basically an isopropyl group. So the name of this substituents you have to put first. Okay, so isopropyl, then you have to put the word cyclo, and as it is a 6-membered ring, so that's why it is hexane. So isopropyl cyclohexane. Okay, similarly you can see that in that second case you have a chloro substituents. Okay, so you have to do the nomenclature in a way: chloro, that is the name of the substituents, then again the prefix cyclo, and then as it is a 5-membered ring, so you have to write pentane, chlorocyclopentane. Okay, now in one case what happened that there can be a situation where the cycloalkane contains one ring and 2 or more substituents. So in my previous slide I have talked about cycloalkane without or with only one substituents, but there can be many cases where the cycloalkane contains 2 or more than 2 substituents. So in that case what you have to do? So first of all you have to do the numbering. Okay, so you can see that cycloalkane with one ring and 2 or more substituents. So in that case, for a ring with 2 substituents, begin by numbering the carbon in the ring starting at the carbon atom with substituents that is first in the alphabet. Okay, and number in the direction that gives the next substituents the lower number possible. Okay, so you can see that this is one example. You in my first part of the lecture I have told you that the carbon atom bearing any hydroxyl group, you have to give this carbon atom the first preference. Okay, so that's why I have numbered this carbon atom which is attached with this hydroxyl group number 1. Okay, then you have to do the numbering in such a way that the second substituent, that is the methyl substituent, should get the lowest number possible. So if you do the numbering in the clockwise direction, in that case only you will get the position of the carbon atom which is attached with the methyl group is 2. That is the lowest possible number. If you do the numbering in the anti-clockwise manner, the position of this carbon would have been 6. That is not acceptable. So this is the right way of numbering. Okay. So after numbering this, you have to then name the substituents first. So 2-methyl. Okay. Then 2-methyl. Then again the position of this hydroxyl group is 1, so that's why 1 cyclohexanol, because whenever you are doing the nomenclature of any alcohol compound, you have to write hexane plus all. I have already told in my first lecture that you have to write hexane plus all, and then you have to omit this part E, so it will be hexanol. Okay, so this is the way you can do the nomenclature of these types of cyclic compounds. Okay. Now here you can see that in this case also there are two substituents, but these are not functional group, these are simple substituents. So in that case, in which way you have to do the numbering? So either you can do numbering like 1, 2, 3, or you can do the numbering like 1, 2, 3. So which way is the proper numbering? So in that case, at first you have to identify what are the substituents present. So the one substituent is methyl and another substituent is ethyl. Now you should concentrate on the first letter of each of that substituents. So in case of methyl, the first letter is M, and in case of that ethyl substituents, the first letter is, or first word is E. So this E basically alphabetically came before M. So that's why while doing the numbering, you have to number this group before this methyl group, because that E word come alphabetically before M. Okay, so the numbering will be like 1, 2, 3. Okay, so during that nomenclature also you have to do follow the alphabetical order. So 1 ethyl, then the position will be, it will be 3. I am sorry for that mistake. It will be 1 ethyl, 3 methyl, then again the word cyclohexane. Okay, here you can see that there is no hydroxyl group, so no you do not have to write cyclohexanol like thing. Simply it is a alkane compound, so it will be cyclohexane. Okay, now here comes the next rule. So there can be 3 or more substituents that may be possible. So in that case, begin at the substituents that leads to the lowest set of number of locands. Okay, so what it says, you can see that this is one example. You can see that there is one cyclic ring, that is 6-membered carbon ring, and there are total 3 substituents. One is methyl, another is ethyl, and another is chlorine. Okay, so these are the name of the substituents. Now suppose you have to you start the numbering like this: 1, 2, 3, 4. So 1, 2, 3, 4. Now you can see that what is the set of number you are getting where the carbon atom is attached with the substituents. That is 1, then 3, then 4. So this is the set of number you are getting where when you are doing the numbering in this way. Okay, in the clockwise direction. But if you do the numbering in the anti-clockwise direction like 1, 2, 3, 4, then in that case, what is the set of number of the substituents? In that case, the set of number will be 1, 3, 4. So in this position of the carbon, the substituents is attached. So these are the set of numbers that you are getting when you are doing the numbering in the anti-clockwise direction, and these are the set of number, that is 1, 2, 4. This is the set of number that you are getting when you are doing the numbering in the clockwise direction. Okay, so you can see that this set of number is the lowest set of number compared to this set of number. So that's why the clockwise numbering is the right way of numbering this cycloalkane compound. So you can see now, while doing the nomenclature of this compound, as this this chlorine group come alphabetically first, so you have to write 4-chloro. Okay, then this ethyl group come alphabetically second, so the position of this ethyl group is 2, so 2-ethyl. Then after that the position of this methyl group is 1, so 1-methyl. And as there is it is a 6-membered ring, so you have to write cyclohexane. Okay, so you can see that the substituents are listed in alphabetically order, not according to the number of the carbon atom. So while doing the nomenclature, you have to follow the alphabetical order, but while you are doing the numbering, you have to follow in such a way that you are getting a lowest set of number. Okay, so if you do have any questions regarding this lecture, you can feel free to ask me. I will definitely try to resolve all of your issue through the comment section. Okay, now you can see that there is another situation, that when a single ring system is attached to a single chain with greater number of carbon atoms. So you can see that this is a 4-membered ring. Okay, you can see this is a 4-membered ring, and this ring is attached with a chain which consists total 5 number of carbon atom. Okay, so whether you will consider it as a cycloalkane or you will consider it as a simple alkane, so that is the question. So in that case, rule number 5 says that when a single ring system is attached to a single chain with a greater number of carbon atom, or when more than one ring system is attached to a single chain, then it is appropriate to name the compounds as cycloalkane. Okay, so you can see that when this single chain is attached to a single, you can see when a single ring system is attached to a single chain, although this single chain is having more number of carbon atom than the number of carbon atom that is present in this cyclic part, but still you have to write it as cycloalkyl alkane. Okay, so in that case, you have to write the name of the compound like cycloalkyl alkane. So you can see that the position of this carbon atom like 1, 2, 3, 4, 5. Okay, so 1, then cyclo, then you can see that it is a butyl pentane. So this group is cyclobutyl group. So you can see that you have to write this as cyclobutyl group because it is a cyclic compound and it contains total 4 number of carbon atoms. So this will act like a substituents. In this case, this is the main or parent chain. You have to consider this as the parent chain. Okay, and this is nothing but the substituents, and the name of the substituents is cyclobutyl, and the position of the substituents is 1 because this cyclobutyl group is attached with number 1 carbon atom. So that's why 1 cyclobutyl pentane. Okay, now in that case you can see that there are total 2 rings are present. So this is a situation number 2, when more than one ring system is attached to a single chain. So in that case, you can see you have to consider this as a parent chain. So you have to number like this 1, 2, 3. This is the numbering of the carbon atom of the parent chain, and you can see that with number 1 carbon atom there is one substituents, and with number 3 carbon atom there is one substituents, and both substituents are basically cyclohexyl. Cyclo because it is a cyclic compound, and hexyl because both the rings are having total 6 number of carbon atoms. So 1, 3 di, you have to write di because there are total 2 rings, 6-membered ring. So 1, 3 di cyclohexyl propane because the parent chain contains total 3 number of carbon atoms. Okay. Now these are some of the problems that I have solved that give name of the following substituted alkanes, and these are the problems I have solve this. If you are able to understand it, it is well enough. If you do have any questions, you can ask me through the comment section. Okay, I am giving one some of them. I am just solving one of this problem, that is problem number F. You can see. So you can see that this is a 6-membered cyclic ring, and you have to, at first you can see that there are basically two substituents or two groups. That is, one is the hydroxyl group or alcohol group, and another, you can see, this is nothing but the tert butyl group. Now while the carbon atom is, when attached with any hydroxyl group, that carbon atom has to be numbered number 1. Okay, and then you have to number in such a way that the second substituents should get the lowest number possible, which is only possible if you go through the clockwise direction. So you can see that the position of the second substituents is number 3. Okay, so that's why 3, then the name of that substituents, that is 3-tert butyl, then the position of this hydroxyl group 1, then cyclohexanol, because it is a 6-membered ring, and as it is an alcohol compound, so that's why hexane plus all, cyclohexanol. So in that way I have also solved or given you the solution of other nomenclature. So if you I hope that you will be able to follow why I am writing the nomenclature like this. If you do have any questions, you can feel free to ask me through the comment section. Okay, now this is also very important. In this slide I will discuss about the nomenclature of bicyclic compound. So the first question that can be arised to you, that why it is called a bicyclic compound. Okay, so if you heard the word bi, then you thought, okay, there may be two cyclic compounds that can be present. That's why we are calling it as bicyclic compound. Okay, now this is an example of bicyclic compound. Okay, so you can see that this is a bicyclic compound, example of a bicyclic compound. Here you can see there are some of the terminology that you have to understood or you have to remember. So those terminology here I am explaining you. So the first terminology is called the bridgehead carbon. Okay, so you can see that these two carbons are basically, you can see, if you just see at a glance, you can see that there are total 2 rings. Okay, so this is one ring. Okay, and this is another ring, and if you see very closely these 2 rings, then you will understood that this carbon atom and this carbon atom, these 2 carbon atoms are common to both of this ring. Okay, so these carbon atoms are called bridgehead. So these are acting like a bridge between these 2 rings, so that's why they are called bridgehead carbon atom. These are basically common to both of these rings. Okay, now the second terminology is called bridge. So you can see that the CC bonds or chain of carbon bond joining these 2 bridgehead carbon are called bridge. So you can see that these are 2 bridgehead carbon atom, and whatever the carbon chain that join these 2 bridgehead carbon is called the bridge. So you can see that this is one bridge. As you can see, this bridge join the carbon this 2 bridgehead carbon atom, and you can see that this is basically 2 carbon bridge, because this bridge consists of total 2 number of carbon atoms. Again, similarly, this is also a 2 carbon bridge which is also joining this 2 bridgehead carbon atom, and you can see this is another bridge, that is CH2, but here you can see this is 1 carbon bridge. So you can see there are total 3 bridges are there, two carbon bridge and one carbon bridge. So this is the terminology that I have discussed to you. So these are the things that you will encounter, that is the word like bridgehead carbon, bridge. So those things you will encounter while you have to do the nomenclature of these types of bicyclic compound. So these types of bicyclic compounds can be drawn like this also and like this also. you can see that if you see that this is one carbon bridge, okay, CH2 group. These are two carbon bridge, you can see, okay, and these two are called bridgehead carbon, okay. So how we should write the nomenclature of these types of bicyclic compounds? That is the million-dollar questions. Okay. So you can see that we name the compound containing two fused or bridged ring as bicycloalkane. Okay. So as it is a bicyclic compound, so you have to write like bicycloalkane. Okay. So you can see that here in this case, you can see that there are total 7 number of carbon atoms are there. So you will write bicycloheptane, okay, because it is a 7 carbon atom. But wait, this is not the complete nomenclature of this bicyclic compound. There is something more to it that I will discuss in the next slide. So this is the proper way of doing the nomenclature of these types of bicyclic compound. Okay, so what is the proper way? At first you have to write this word, that is bicyclo. So whatever the bicyclic compound you will encounter, at first you have to write this prefix bicyclo. Then you have to draw one third bracket, that is common. Okay, after that what you have to do? You have to count the total number of this bridge carbon. Okay, so you can see that this is two carbon bridge, you can see, and this is also a two carbon bridge, and this is a single carbon bridge. Okay, so then you have to write in such a order that it is in order of decreasing length. Okay, so you can see that these two are two carbon bridge, so this two will come first, and then as it is a one carbon bridge, this one will come first. So these number basically specify the number of carbon atom that is present in each of this bridge. Okay, as there are total 3 bridges, so you can see this 2 to 1, so 3 numbers are there, and these numbers signifies the total number of carbon atom present in each of this bridge. Okay, so then bicyclo, then the third bracket 2 to 1, that is the number of carbon atom in each of this bridge, and then heptane because it contains total 7 number of carbon atoms. Okay, so bicyclo, third bracket 2 to 1 heptane. Now what is the nomenclature of this compound? You can see that all these types of rings are basically called the bridged ring. Why it is called the bridged ring? Because you can see that there is at least one carbon atom that is present in the third bridge. You can see, that's why they are called bridge ring. But if you see in that case of third bridge, these two bridgehead carbon are directly attached by these types of carbon-carbon bond. There is no CH2 type of bridge. So that's why these types of compounds are called fused ring compound. So these two rings are basically fused together. There is no middle bridge or present in these types of compounds. So that's why these are called the fused ring. And as there is one carbon bridge is present in these types of compounds, so these are called bridged ring compound. Okay. Now if you see that in this case there are two one carbon bridge, so bicyclo again third bracket 1 that is the total number of carbon atom present in each of this bridge, and in the middle bridge as there is no carbon atom, so that's why you have to write 0. So bicyclo 110 butane. If there is a 0 number, then you should understood that it is a fused ring compound. Okay, butane because it contains total 4 number of carbon atom. Now suppose these examples, in this example these types of bicycloalkanes do not contain any substituents, but what happen if these types of bicycloalkane compound also contain substituents? That then in that case you have to do the numbering of this carbon atom. Okay, so rule number 3 says in bicycloalkane with substituents we number the bridged ring system beginning at one bridgehead, so and proceeding first along the longest bridge to the other bridge, then along the next longest bridge back to the first bridgehead. the shortest bridge is numbered last. So first of all, you have to start with any one of the bridgehead compound, bridgehead carbon. So you can see that these two carbon atoms are basically common to both of these two rings. So that's why these two carbon atoms are called the bridgehead carbon. So let's first start with this bridge carbon. Okay. Now, in which direction you have to do the numbering? Whether you have to do the numbering in anti-clockwise direction or you have to do the numbering in clockwise direction, that will be decided by the total number of carbon atom that is present in the chain, in the bridge. Okay, so you can see if you go through this clockwise direction, there are total 1, 2, 3 number of carbon atom that is present in that bridge. On the other hand, if you do the numbering through the anti-clockwise direction, there are total 2 number of carbon atom that is present in the bridge. So in that case, you have to do the nomenclature along the longest bridge to the other bridge head. So always you have to do the numbering in such a way that at first it encounter the longest bridge. So that's why the clockwise nomenclature, the clockwise numbering you have to do. So 1, 2, 3, 4, 5, then 6, 7. Okay, this is the way, and then you can see that this carbon, that is the third bridge. That is the third bridge you have to do the, and this carbon will get the highest number. Okay, so you can see that you have to do along the long side to the other bridgehead. You can see at first you have to go through to the other bridgehead. Then after that, the last carbon atom should be numbered. That is 8. And you can see that at the 8th position there is one substituents that is called the methyl substituents. Okay, so 8 methyl, then again this bicyclo, then third bracket, then you have to write the total number of carbon atom that is present in each of this bridge. So you can see that in one bridge contain total 3 carbon atom, the second bridge contain total 2 carbon atom, and the third bridge contain only 1 carbon atom. So you can see that this is the shortest bridge, and you have to do the nomenclature in such a numbering in such a way that the shortest bridge head or the shortest bridge should be numbered last. So that's why it is numbered last. So 8 methyl bicyclo 321 and octane, because it contains total 8 number of carbon atoms. Okay, now this is a example of a bridge ring. Now if you see this one, you can see that this is not a bridged ring, this is a fused ring, because that in case of there is no third bridge. So in this case there is no bridge, the 2 carbon atoms are directly joined together, so that's why they are called the fused ring. Now in that case you have to start the numbering from one of the bridgehead. Suppose these two are bridgeheads, so suppose we start with this bridgehead, then you have to go in such a way that you have to at first pass through the longest bridge. So if you go through the clockwise direction, you will encounter total 1, 2, 3, 4 number of carbon atoms. On the other hand, if you go through the anti-clockwise direction, you will encounter total 3 carbonate bridge. So this is the longest bridge, so you have to do the nomenclature along the clockwise direction. So 1, 2, 3, 4, 5, 6, then 7, 8, 9. So you again came back to the first bridge. So as there is no third bridge, third bridge, so you do not have to do the nomenclature or numbering for that carbon. Okay, so you can see that there is only one substituent, that is methyl substituents, and the position of this methyl substituents is 8. So 8 methyl, then the word bicyclo, then you can see that this bridge contains 3 carbon, total 4 carbon atom, 1, 2, 3, 4. So that's why 4, and this bridge contain 1, 2, 3 carbon atom, and there is no third bridge. So that's why it is, you have to write 0. Although there is no third bridge, but still for the sake of completicity, to complete this, you have to write 0. So 430, then non-n, because it contains total 9 number of carbon atoms. Okay. Now here I have solved the in my previous slide, I have showed you that how you can do the nomenclature of these types of bicycloalkane. But what happened if you suppose you have given a name of the structure, that is 7,7 dichlorobicyclo 2,2,1 heptane. So suppose that you have given the name of this bicyclic compound. So by seeing the name of this compound, how you can draw this compound? So that is another task, because in my previously from the structure itself we are doing the nomenclature. But let's think in the reverse way, that we have provided with the nomenclature of this compound and we have to draw the structure of this compound. So how we could do that? It is 7,7 dichlorobicyclo 2,2,1 heptane. Okay, so at first you have to consider this number 221. So this number basically signifies the total number of carbon atom that is present in each of this bridge. So one bridge contain 2 carbon atom, another bridge contain 2 carbon atom, and another bridge contain total 1 carbon atom. So these are the number of carbon atoms. So that is the first thing you should consider. Now you can see that the last word, that is heptane. So it is a 7-membered so in this bicyclic compound there are total 7 number of carbon atom. So you will write like this at first. So you can see that the first bridge, that is contain 2 carbon atoms, so that's why you have written 2. And now the second bridge, that also contain 2 carbon atoms, so that's why you write this. And the third bridge, you have to join these 2 bridge head like this, because it has only 1 carbon atom. So this bridge contain only 1, so like this. So 2 to 1 heptane, that is completed. Now there is a substituent, that is 7,7 dichloro. So after that you have to do the numbering itself. Okay, so how you could do the numbering? So first you should start with 1 bridge head. Okay, 1, then 2, 3, 4, 5, 6, and you can see that the shortest bridge head should be numbered highest, so 7. So in that 7 position there will be 2 chlorine group. So this is the structure. So here I am drawing this structure more beautifully. Okay, so this is the structure of this compound 7,7 dichloro bicyclo 2,2,1 heptane. Okay, so these are some of the problems that I have solved. So you can see that these are the structure. So these are the bicyclic compounds that it is drawn, and it is asked that what is the nomenclature of this type of bicyclic compound. So I am not explaining each of this here, I am explaining only this last one. Okay, so you can see that this is the structure of the last one. You can see that there is one substituent that is present in this bicyclic compound, that is methyl substituents. So at first you have to do the numbering. So the numbering should start at any one of the bridgehead. That is, suppose we start numbering like 1. So you can see that the numbering start at this bridgehead carbon, that is number 1. Then you can do the numbering in this way, like in the clockwise direction 1, 2, 3, 4, 5, 6, or either you can go in the anti-clockwise direction, that is in this direction. So which direction you will choose, so that will be dependent on the position on this methyl substituents. Okay, so while doing the numbering of this carbon atom, you have to consider that the carbon atom that is attached with this methyl substituents should be numbered as low as possible. That is one of the rule for the IUPAC nomenclature of organic compounds that I have discussed in the part 1 of this lecture series. Okay, so you can see that if you do the numbering in the clockwise direction, like 1, right from this bridgehead position, 1, 2, 3, 4, 5, 6. So in that way you can see that the carbon atom that is attached with this methyl substituents is now number 2. That is the lowest possible number that it could get. So this is the correct way of numbering the carbon atom in this bicyclic compound. So it will start from this bridgehead carbon 1 2 3 4 5 6, then it will goes to 7, okay, 7 and 8. So this is the last bridgehead. Okay, now you can see that at first you have to write the prefix, that is the position of the substituents, that is 2, then the name of the substituents, that is methyl, then bicyclo, then third bracket, then that is you have to write the number of carbon atom that is in forming the 3 chains. So you can see in the first chain it consists of 2 carbon atoms, so that's why 2. Second chain or second bridge also contains 2 carbon atoms, and the third bridge also contains 2 carbon atoms. So 2 2 2, then again write the third bracket, then octane, because the bicyclic